In this module, let us learn how to solve geometric problems involving all the formulas that you have learned thus far, from distance, midpoint, parallel, perpendicular, as well as area rectilinear figures. Let us now turn to page 102 of your notes. The first example is given to you with a diagram on the right side. The diagram is not drawn to scale, shows a triangle in which the point A is 8, 8, and the point B lies on the y-axis. For the fact that it lies on the y-axis, the first thing you will know of is that the coordinate has 0 something. So that's the first thing you already am able to find out. The point C lies on the perpendicular bisector of AB. So if you actually draw a perpendicular line down, you will note this is a perpendicular line. Not only is it perpendicular, it bisects these two. So essentially, this point here is actually the midpoint. Right? So these are things you already know from the para. Now, maybe let me write the M properly so that we can all read the M together. All right, so this is point M. It also says that the equation of the line BC is y equals to 8x minus 4. So BC, this line, y equals to 8x minus 4. So these are the information provided to you in the para. First and foremost, they want you to find the coordinates of B. Coordinates of B, we know that the x value for B is actually 0 because it sits on the y-axis. At the same time, the equation of BC is actually given to you, given that it is y equals to 8x minus 4. So for part A, with y equals to 8x minus 4, and when your x is equal to 0, we can then substitute to find the y value, which is 8 times 0. Oops, the 0 there doesn't look nice like a 0. All right, this is a 0 minus 4. We can then therefore say that y is negative 4. Therefore, given this, b is actually 0, negative 4. All right, and that's for part A. Now in part B, the equation of the perpendicular bisector of AB. So the equation of the perpendicular bisector of AB. So essentially it's talking about the equation of CM in the diagram that I have drawn. CM. We know that CM is perpendicular to AB. So if AB's gradient is if we can find AB's gradient, we know that the gradients are related. All right, then in order to find equation, not only do I need to know the gradient, I need to have at least a point that sits on the line that you want to find, a point that sits on CM. So the fastest way to get the point is to use M, or to find out M, because M is the midpoint of A, B. All right, so let's go to part B and work things out. So in part B, let's go find the midpoint of AB. To find midpoint is average of the average. So we have 8 plus 0 divided by 2. And then we have 8 plus negative 4 minus 2. So midpoint in this case will give you 4, 2. Knowing the midpoint, let's find gradient then. So to find gradient of AB first, so that we can find CM. Gradient of AB, we know it's y1 minus y2 over x1 minus x2. This will then give us 12 over 8, which we can reduce it to 3 over 2. So therefore, gradient of perpendicular bisector is equal to negative 1 over 3 over 2, which is negative 2/3. Knowing that the gradient of the perpendicular bisector is negative 2/3, let's form the equation then. Therefore, we have equation of perpendicular bisector is y, and the coordinate we can use is m coordinate. So y minus 2 is equal to negative 2/3 x minus 4. This is the generic form for equation of straight line. So if I were to tidy this, I get negative 2/3 x. This one, negative 2/3 times negative 4 will give me plus All right, and then of course the that's plus 8 over 3 plus 2, so that's 14 over 3. So if I want to write it in non-fractional, I get negative 2x plus 14. There you go, equation of perpendicular bisector. Part C wants me to find the coordinates of C. I have now found the equation of CM in this diagram. I have also got the equation of BC. We note that the point C actually sits on both the equation of perpendicular bisector as well as the equation of BC. Therefore, I can actually solve them simultaneously. So let me draw. All right, so for part C, to find equation of C, given 3y equals to negative 2x plus 14, given y equals to 8x minus 4. All right, I'm going to sub my second equation into my first equation, and that gives me 3 times 8x minus 4 equals to negative 2x plus 14. 24x minus 12 is equal to negative 2x plus 14. I will have 26x equals to 26. X is equals to 1. Therefore, my y is equals to 4. So my C is 1, 4. Let's put C back to the equation, the diagram. So now I have 1, 4. The next part, the point D is such that ACBD. Remember we talked about this, the labeling matters, it goes in one direction. So if we have A, we have C, we have B, it simply means that D must be here, somewhere here, all right? So if I were to draw this, I'm seeing a rhombus, something like this with point D, right? ACBD is a rhombus. Rhombus means equal length. All right, find the coordinates of D. Find the coordinates of D. Aha, rhombus. We know one property of rhombus such that the diagonals, all right, the diagonals, you have your two diagonals here, they will intersect at 90 degrees. All right, that's one property of rhombus we know. There must be a purpose why they tell you rhombus. So other than that, we also know that the midpoints of AB and the midpoints of CD are actually going to be equal. This point here is actually the midpoint of both diagonals. Let's use midpoint to solve it. All right, since we know the 2 points already, so the midpoint of AB is the midpoint equals to the midpoint of CD. So I know this is part D, midpoint of AB is equals to midpoint of CD. So midpoint of AB, I have the coordinates. I have a 8 plus 0 divided by 2 is the same. For y will be 8 plus negative 4 divided by 2. This is the same as my CD. So I have 1 plus x over 2. And then I have a 4 plus y over 2. Draw my conclusion. I know 8 plus 0 over 2 is equals to 1 plus x over 2. That leaves me with 4 equals to 1 plus x over 2. That's 8 equals to 1 plus x. Therefore, x is equals to 7. Another conclusion I can draw is that 8 minus 4 over 2 is equals to 4 plus y over 2. So I know this is 2 equals to 4 plus y over 2. 4 plus y equals to 4, y equals to 0. Therefore, you get your point D. D is 7, 0. Let's put 7, 0 in the diagram and check out what they want in the last piece. 7, 0. Part E, not difficult. The area of rhombus ACBD. All right, area of rhombus of any polygon, we can actually use our general formula there. So if I may have my E, I know area of, in this case, rhombus is as good as half. And then we have to choose somewhere to start. Mrs. Chow loves to use 0, -4 because I love 0. And then in anti-clockwise direction, I have another 7, 0. I have a 8, 8. I have a 1, 4. And then I repeat 0, -4. Half 0, 56 plus 32 plus -4 minus 0 minus 8 minus 0 minus -28. This calculated, you get half 104, and that leaves you with 52 units squared. There you go, a full question to solve using geometrical properties that you already know of shapes as well as the formulas that you already have.